In this video, we will be talking about Mr. John Coburn's Precalculus, Exercises 7.1. Now, the 7.1 is also considered as Chapter 8.1, Chapter 3.1 in the Philippine edition. I'm not sure, but this is the chapter according to the PDF. So that's just a clarification. This chapter is all about oblique triangles and the law of sines. So I won't be speaking that much since the concepts are pretty easy to understand. You'll be good if you follow what I'm going to write, and you'll get the hang of it one day, sometime. So you have to take note of this formula. The law of sines basically state that sine A over A is equal to sine B over B, which is also equal to sine C over C. So let's start. So please set your scientific calculator in degrees. So also know that we're going to assume the equal sign being the approximately sign. Okay. So basic algebra manipulation. But this time we're involving things such as sine, cosine, and tangent, and probably their inverses, their respective inverses. Okay, let's deal with number 7. So basically, I multiplied both sides with A, and at the same time I multiplied both sides with 15. So the denominators of the initial equation would be eliminated. With that in mind, we have we divide both sides with sine 32 degrees. The answer would be 9. There is no specific unit of measurement for the length of, assuming we have a triangle, there's no specific unit of measurement, so we just leave it without a unit of measurement abbreviation. According to the book, number 7, the answer is approximately 8.98. But that's already basically 9. So I don't think the teacher would be too strict in regards to the specific decimal quantity. They're literally practically the same. So, okay, let's go with number 8. So that's answer for number 8. Number 9. There you go. And divide both sides with, I suppose, 21.9. and look for the arc sine of everything in this fraction. Angle C would be equivalent to 49.2 degrees. Okay, number 10. Write this. Divided by 6.28. And as usual, look for the arc sine of that very fraction. The answer would eventually be 0.5 degrees. Okay, let's go with number 11. Then divide the right side with 43.2. Angle C is the arc sine of this fraction. The calculator would say it's approximately 21.4 degrees. Okay, number 12. Angle B is equal to the arc sine of 190 sine 38 over 125. Answer is 69.4 degrees. Okay, let's move on to number 13. So we have to solve each angle using the law of sines. We have to draw or label a triangle. So for number 13 and 14, the triangles are already displayed based on the specifications that are stated. Everything that you have to know in order to solve the missing sides and angles. Okay, so we know side A and side B. By the way, we have to assume that the triangle illustrations are not always right angled. So yeah. For 13, we can look for side C with the formula 180 degrees minus angle A minus angle B. That is 180 degrees minus 38 degrees minus 64 degrees, which is equal to 78 degrees. Hence, the value over there. We know the side of angle A, which is basically side A. Let's look for side B and C. Okay, to look for side B, we know that we have the value of sine A, angle A and side A. To look for side B, we know the angle of B, but we're looking for side B. So this is the formula that we'll be using. So sine 38 degrees over 75 centimeters is equal to sine B, or sine 64 degrees, divided by letter B. So basic algebraic manipulation. Okay, have that. B is equal to 109.5 centimeters. Now let's look for side C. So sine A over A is equal to sine C over C. Sine A over A is basically sine 38 over 75. That would be equal to sine 78 degrees over C. Now, we have C sine 38 is equal to 75 sine 78. C is equal to 75 sine 78 divided by sine 38. Oops. That would be equal to 119.2 centimeters. That's for side C. Let's move to number 14. So as usual, we know angle A and angle B. Therefore, angle C would be equal to 180 minus 47 minus 108. That is 25 degrees. I'll just box the missing values. For number 13, we were supposed to look for 3 values. That would be angle C, side B, and side C namely. For number 14, we now know that angle C is equal to 25 degrees. And what we're supposed to look for right now is side A and side C. For side A, we know that angle B and side B are known. And let's use sine A over A to look for side A. So sine 47 degrees divided by 385 is equal to sine 108 over A. Now, algebraic manipulation, the usual strategy. Divide this by sine 47. And we get 500.7 meters. Now, let's go with looking for side C. Sine B over B is sine C over C. Fill in the known values. C is equal to 385 sine 25 divided by 47 sine 47. That would be 222.5 meters. Particularly for numbers 13 and 14, we have specific units for the side values, but initially in this part there are no specific units, so we just write the numbers, nothing else. Okay, let's go for number 15. So this time it is suspected that the given values make up a right triangle. For what reason? Well, it's pretty hard to point out right now, but we do know that theoretically, if we look for the C angle, that's basically 180 minus the angle A, which is 330, and the value of angle B, which is 60. So C is equal to 90. If one of the angles of a triangle has a value of 90 degrees, then obviously the triangle is a right triangle. It's that's one way as to how we could identify if a triangle is a right or not. So given side B is 10 times the square root of 3 inches, we are missing side A and side C. So what we want to do right now is either look for A or C. I'll go for A first. So sine B over B is equal to sine A over A. Sine 60 degrees over 10 times the square root of 3 is equal to sine A, or which is sine 60 over A. A sine 60 is equal to 10 times the square root of 3 sine 30. A is equal to 10 times the square root of 3 sine 30 over sine 60. So A is 10 inches. Let's look for C. Okay, the answer for C is 20 inches. I suppose that's everything for number 15. 3 values missing. We found each and every one of them. Let's go with 16. So we know that our angle C is 180 minus 98 minus 27, which is 55. Oops, don't forget the degree symbol. Otherwise, that's going to be wrong. Partially wrong. Quantities without units can be extremely misleading and could cause catastrophic consequences. So always remember to write the unit if there is a unit. So what we're missing is B and C. By the way, initially, the picture, what's given in the book, there is no specific label as to what is A, B, or C, or angle B, angle A, or angle C. Just assume, try assigning the given quantities a specific assumed value, or if it's example, for 98 degrees, you could write it as angle A or angle B or angle C. It depends. Be resourceful in that regard. You're given the liberty to assign according to your own liking. So yeah, we know that C and B are missing. Let's solve for B first. So sine 27 over 7.2 is sine 98 degrees over B. B is equal to 15.7 meters. Okay, let's look for C. Okay, so all this would eventually equate to 13.0 meters, or just 13 meters. Let's proceed with 17 and 18. So angle C is 180 minus 102 minus 33, which is 45 degrees. And we have to look for the C and A sides. Now, we have side A, side C. Given that angle B is 102, so sine 102 divided by side B, which is 19 inches, that would be equal to sine A, angle A, divided by side A, by which sine A is sine 33 degrees. Now, we know the drill. Afterwards, A would be equal to 10.6 inches. For side C, still use sine 102 over 19, or sine B over B. This time, sine 45 degrees over c. C is equal to 13.7 inches. Okay, for number 18. So, angle C is equal to 180 minus 121 minus 29. That is 30 degrees. Now, let's look for side B first. Then later on, we look for side C. Sine A over A, we have sine 29 over 89. The final answer would be 157.6 yards. The unit of the sides this time would be yards, as you can see here. For side C, we used the same sine A over A. And for side C, that's it. Sine 29 degrees is equal to 89 sine 30 degrees. C is 91.8 yards. Okay, let's go with 19 and 20. I just want to see which. Okay, so far so good. We're almost done with this video. I think we're halfway, or more than halfway. Probably 60% done. Let's go with 19. So provided that two angles are the same value, 45 and 45, obviously the other angle, that is C, that would be 90. So obviously you could say that this is a 45, 45, 90 triangle. Therefore, given that side C is 15 times the square root of 2 miles, I'm starting to guess, this is just a wild guess, A and B are 15. They're both 15. But let's see. Let's not take shortcuts. Let's use the traditional generic method. So we know the three angles now. We have to look for side A and side B. Now, for side A, we have let's try sine C over C. That is sine 90 degrees over 15 times the square root of 2. Okay, so a sine 90 degrees is equal to 15 times the square root of 2 sine 45. So yeah, A is equal to 15 miles. I bet the side B is also 15. Well, based on what you can see right now, if you compare this equation with this one, the only difference is the side, the denominator of the right side's fraction. So theoretically, you could say that B is also 15 miles. That's it for number 19. Pretty easy. If you could observe the pattern, then you could understand it more easily. Let's go with number 20. Okay, so right now we know angle A and angle B and side C. Let's look for side or angle C. Angle C is 180 minus 20.4 minus 63.4 degrees. That would be equal to 96.2 degrees. With that in mind, let's look for sine B over B. Let's look for side B, and later on let's go for side C. For sine C, we have sine 96.2 degrees over 12.9 miles, which is equal to sine 63.4 degrees divided by B. Okay, so according to the calculator, letter B is 11.6 miles. Let's look for A. A is equal to 4.5 miles. go with number 21. Angle A is 180 minus 103.4 minus 19.6. That is 57 degrees. That's angle A, as you can see here. Let's look for side B. B is 49.5 kilometers. Now let's go for C. The answer for letter C is 17.1 kilometers. In number 22, let's look for the angle C. That is equal to 145 degrees. Okay, let's look for side A. So A is equal to 49.5 miles. Let's look for side B. B is equal to 82.4 miles. Okay, let's go with number 23. For 23, we have to look for angle C first. That would be equal to 180 minus 56 degrees minus 112 degrees. Angle C therefore is 12 degrees. Now, we know that B is missing as well as side A. So, let's look for side A first. A is equal to 3.2 centimeters. That's number 23. For 24, angle C is equal to 180 minus 37 minus 47. That is 96 degrees. And we know that what's missing is the side A and the side B. Let's look for side A first. For side B, sine C over C is equal to sine B over B, such that sine B is sine 47 degrees, and for sine C, it's sine 96 degrees over C. C is 27.5. B is equal to 20.2 centimeters. Alright, I'll be skipping numbers 25 to 30, 31, 32, all the way to 38, as well as 45. I will resume from 39 to 44. So as I said here, I'll be looking for the unknown angle, but I won't be looking for this one. If I'm supposed to determine if a second angle exists that also satisfies the proportion. For number 39, the missing value is angle A. Divide both sides with 27. If I'm not wrong, the other angle would be basically that would be equal to 180 degrees minus angle A sub 1. Therefore, angle A2 would be 160.7 degrees. This is the second angle. For number 40, divide both sides with 32. For angle B sub 2, that's going to be 180 minus 14.1, which is 165.9 degrees. Let's go with 41. Angle C sub 1 is 71.3 degrees and angle C sub 2 is therefore 108.7 degrees. One thing that you could do to make sure that your angle sub 1 and angle sub 2 is correct, they should be the sum of 180, exactly 180. Angle B sub 2 is 105.9 degrees. Last two questions and we're done. Technically, if you place this in the calculator, the answer would be undefined. If I'm not wrong, the calculator would say that it's a math error or something relevant to that. Let's try number 44. Technically, the answer is also undefined. That means there are no solutions. Solutions aren't possible. Okay, that's it for this video. This is all the answers that I could provide for as a walkthrough for exercises 7.1 or 3.1. Thank you.